This is lesson 11.4, triangle area and trig applications. Our objectives today are to be able to find the area of a triangle without knowing the height, and to be able to use the law of sines and law of cosines to solve application problems. So the first thing we want to learn is area of a triangle if you don't know the height. So remember, in the past we've learned if you drop a height down like this, that's the height, then we learned that the area is 1/2 base times height of a triangle. But what if you don't know the height? So notice when we drop that height down, what we've made is a right triangle right here. So we've made a right triangle, right? And if we look at angle A, when we have right triangles, we could use SOHCAHTOA. So sine of A is equal to that height over C, which is now the hypotenuse of that blue right triangle, right? So if we were to multiply both sides by C and solve for H, we learn that the height is the same thing as C times the sine of A. So if we take this and substitute it in our area equation, we get area equals 1/2 base times the height, which we now know is C sine A. And look at what we got, right? So area. We just got 1/2 BC sine A, which is exactly what this is. So there's 3 variations of this formula just because it depends on which angle you choose, right? So it depends on which angle of the triangle you have, right? If you have angle C, if you have angle B, or if you have angle A, right? So basically you have to know side A, side B, and then the angle between them, right? In other words, you have to know side angle side in order to use this. All right, so let's look. Right? To find the area, we need side angle side. So we might not always be given side angle side, so sometimes we'll have to do some solving until we get side angle side, and then we can use the formula. So let's try it. So we have side angle side on this one. So area is 1/2 times the 2 sides times the sine of the angle in between them. Very important. You have to do the angle in between, right? Side angle side. The 2 sides you use and the angle in between them, right? That's what you have to have. All right, so now all we have to do is type this in the calculator, right? And again, just like the whole unit, really make sure that your calculator's in degrees mode. You don't want to mess up because you didn't have it in degrees mode. That would be really sad. So I'm going to type 1/2 times 23 times 14 sine 94. And I get that the area is 160.60, so we'll round to 160. And then this is area, so you remember the area is always square units, right? So we can pretend like this one was in inches. You'd have to write inches squared, right? All right. Next one, A equals 76, B equals 11, C equals 24. So let's draw the picture. So A is 76, little b is 11, little c is 24. Do we have side, angle, side? Yes, we do. Side, angle, side. Okay, so area is 1/2 times the 2 sides times the sine of the angle between them. All right, so now I'll type that in. 1/2 times 11 times 24 times the sine of 76, and I get 128.07, so I'll round it, square meters. Okay, not bad, right? Next one. So they've given us A, B, C. So they've given us 123 degrees, 21 degrees. Small a is 6, small c is 3. So first check, do we know side angle side? We don't, right? We would need to know angle B in order to have a side angle side. But luckily, the 3 angles add to 180, so it's really easy to find out what angle B is. So 180, subtract 123, subtract 21, and so that's 36 degrees. So now we can do area is 1/2 times the 2 sides times the sine of the angle between them. Okay, so I'll type that in. 1/2 times 3 times 6 times the sine of 36. And I get 5.29, so 5.3 centimeters squared. Okay, next one, the dimensions of a triangular flag are 15 inches by 21 inches by 33 inches. What is the area of the flag? So remember, we need to find an angle. We have all three sides, so it doesn't matter which angle we find. Let's just label these A, B, and C really quick. So you can pick any angle you want. So let's say we want to solve for angle C. Remember that side, side, side calls for law of cosines. So if we want to solve for angle C, we start with side little c on the outside, right? And then set it up. It begins to look like Pythagorean theorem. And then we add on this part, so cosine of C. Okay, so this one, to get the cosine of C by itself, we have to subtract off those two parts and then divide by the -2 times 15 times 33, which is all multiplying by cosine of C. That's why we divide. And then we'll have to do the cosine inverse to get that out of the C. So I'm going to type all this 21 squared minus 15 squared. I'm going to type all that in my calculator and see what I get. Okay, so you type that in and I get 0.881, and then I'll do the cosine inverse of that, and I find that my angle is 28.13, so 28.1 degrees. So now that we know angle C, we can do the area formula. And then remember that you need to use the sides on either side of the angle. You have to have side, angle, side, right? So we have to use 15 and 33. So the area is 1/2 15 times 33 times the sine of 28.1. So I'll just type that in my calculator and see. So 1/2 times 15 times 33 times the sine, and I get 116.7, and the units they gave us are inches, so square inches. Next one. Two observers are 1.8 miles apart on opposite sides of a hot air balloon. The angle of elevation from observer A is 41 degrees, and the angle of elevation from observer B is 34 degrees. Find the altitude of the balloon. All right, so let's draw a picture. So here's our balloon, right, hot air balloon, and we have two observers 1.8 miles apart on opposite sides. So observer A is looking at 41 degrees, and observer B is looking for up at 34 degrees, and we're trying to find the altitude, right? So that's going to make a little right angle down there. Okay, so this is going to be crazy, right? So this problem is kind of difficult, so the way we want to approach this is, if you want to find the height, right, we need to know either this side or this side first, because we have made a right triangle in here. So we can do sine of 41 is the height over the hypotenuse, or sine of 34 is the height over the hypotenuse, and then solve for the height, right? But we can't do that unless we know one of these two sides. So we have to first look at the larger triangle, right? So we have to look at the larger triangle first before we can do that. And we have to solve for one of those missing sides, okay? So we can solve for this angle C so that I have a side across from an angle, right? So 180 minus 41 minus 34. Okay, so 180 minus 31 minus 34 gives me 115 degrees for this angle. So now I can set this up with law of sines, and we can solve. So it doesn't matter which one we solve for, right? I could solve for little a, or I could solve for little b. So let's solve for, how about little b? So I'll use angle b to solve for little b. So 1.8 sine 34 equals b times sine 115, and then divide off the sine 115. Okay, so I'm going to type all of this in my calculator and see how much b is. Okay, so I get b is 1.11. So now I can look at this right triangle in here, right? So I just solved for this 1.1 and I'm looking for h. Well, you know that in a right triangle with SOHCAHTOA, the sine of 41 is going to be opposite, that's our height, over the hypotenuse, which is the 1.1. And then we can multiply both sides by 1.1 to solve for h. So h is going to be 1.1 times sine of 41. And we type that in and we get 0.72. And then what is this? Miles. Always do the units. Okay, so that's a bit of a complicated one. You kind of have to split it into two parts with the bigger outside triangle and then the smaller right triangle. All right. Next one. After a windstorm, you notice that your 16-foot flagpole may be leaning, but you're not sure. From a point on the ground 12 feet from the base of the flagpole, you find that the angle of elevation to the top is 47 degrees. Find the angle to the nearest degree that the flagpole makes with the ground and determine if it's leaning. Okay, so we'll make a nice, possibly leaning flagpole, right, with the ground. And it's 16 foot, so that's the height. And you're 12 feet from the base. And the angle of elevation to the top is 47 degrees. So we want to find the angle right here and see if it's leaning. Of course, if it's straight, it's going to be 90 degrees, right? Okay, so we can't use SOHCAHTOA on this because we don't know if it's a 90-degree angle. SOHCAHTOA only works if it's a 90-degree angle, and we're going to assume that it might not be. So what we're going to use instead is law of sines and cosines to solve for this missing angle. All right, so I do know 47 degrees across from 16, but I don't know what the side across from the missing angle is, right? So we might have to solve other things first, right? All right. So let's first solve. We'll set up sine of 47 over 16, and we'll get this unknown angle. Let's just label these real quick. It always is helpful to label. We can set that up with sine of a over 12, because if we solve for a, we'll know two of the three angles, and then we can solve for c easily by subtracting from 180. So 12 sine 47 equals 16 sine a. The a is trapped inside the sine, so all we can do is divide off the 16, and then we'll have to use sine inverse to get the a out of the sine. Okay, so I'm going to type 12 sine 47 divided by 16 in my calculator, and I get 0.548. And then do the sine inverse of that. Okay, and I get 33.26, so 33.3. All right, so that was angle A. So now if we want to find the last angle, we can minus off the two that we know, right? So 180, subtract the angle that we just found, 33, subtract 47, and I get that it's 99.7 degrees. So that is not 90, it is leaning, right? So remember, this had two parts, find the angle and determine if it's leaning. So you need two parts to your answer, find the angle and it is leaning. Okay. Next one, this is the last one. A surveyor needs to determine the distance between 2 points that lie on opposite banks of a river. 2 points A and C along one bank are 120 yards apart. B is on the opposite bank. A is 57, C is 62. Find the distance between A and B. So you know it's a triangle problem, so don't worry too much about trying to like draw some complicated thing. Make a triangle, right? So it says A and C are 120 yards apart. Angle A is 57, angle C is 62. Find the distance between A and B. All right, so let's look at what we have. Do we have sides across from angles? And I do. I have 62 across from my side that I'm trying to find. But I don't know the side across from this, and I don't know the angle across from that, so that's not going to work. So let's solve for something else first, right? You're sensing a common theme here. You always have to do multiple steps. You can never get what you want in just one step. Okay, so let's try instead. Let's solve for angle B. Angle B is easy to get, right? It's always nice when you have two of the three angles because you can easily get the third one. So I'll just type 180 minus 57 minus 62, and now I know that angle B is 61, right? And now I have a known angle across from a known side. So I can set up sine 61 over 120 and sine 62 over what I'm trying to find, x. So 120 sine 62 equals x sine 61. The x is not stuck inside the sine, so I can divide off sine 61, and that will give me the value of x. So I'm going to type in 12 sine 62 divided by sine 61, and I get 12.11, so 12.1, and we're in yards. All right, so now try your homework. Send me questions through email or on the Zoom office hours or the Remind app, and thanks for watching. Good luck.